In order to solve a system of equations, I need to find an x and a y value that make both equations true. If I look at each equation separately, I really have a collection of ordered pairs, a collection of points that make each equation true. If I were to graph each equation, I'm really graphing two lines. So to solve a system of equations, I'm really finding out how two lines relate to each other. One way that two lines can relate to each other is intersecting lines. If I think of intersecting lines as a system of equations, what ordered pair, what x, y value makes both of these lines true? What makes both of these equations true? Well, it's got to be this point right here. This is the point that's on both lines. Intersecting lines give me one solution to my system, and it's at the ordered pair x, y. Another way lines could relate to each other. If I have two lines that never intersect, I end up with parallel lines. If you think of parallel lines as a system of equations, how many times do these lines intersect? Well, the answer is never. So this system actually has no solutions. There are no ordered pairs that make both equations true. The third way that lines can relate to each other. Two lines could be right on top of each other. It's tough to draw two lines right on top of each other, so I'm just going to draw two lines on top of each other. When two lines are on top of each other, they're known as coincidental lines. Co means together, incident means happening. Coincidental means together, happening at the same time. Two lines right on top of each other. So how often do these two lines intersect? Well, they intersect at every point. They intersect infinitely many times, so there are infinite solutions to this system of equations. Let's solve a system. The first method to solve a system, we're going to use linear combination. Last year, you might have called linear combination elimination. To do linear combination, we're going to multiply both equations by numbers so that the coefficients for one set of variables are opposites. I can either make my x coefficients opposites or my y coefficients opposites. I'm going to pick my x's. I need to make my x coefficients opposite of each other. So I look at 6 and 2. The least common multiple between 6 and 2 is 6. Well, I want to make this 6 just a normal 6, so I'm going to multiply by 1. And I need to multiply everything in my equation by 1. Now I want to make the x in my second equation negative 6. So to turn this 2 into a negative 6, I need to multiply by negative 3. So I'm going to multiply everything in this equation by negative 3. I'm going to distribute this negative 3 to every term. After I've multiplied by numbers to make my coefficients opposite, I'm going to add. 6x minus 6x gives me 0. My x's are eliminated. Negative 4y plus negative 6y gives me negative 10y. 11 plus negative 21 gives me negative 10. Notice how I have an equation with just one variable. Now I need to solve that equation for my remaining variable. I'm left with y equaling 1. Well, I need to find the ordered pair that makes both equations true. Right now I just have my y value, so I need to figure out my x value. In order to figure out my x value, I'm going to substitute in my value for y and solve for x. Doesn't matter which equation I pick, I'm just going to pick the first equation. Plug 1 in for y. Now I only have one variable left in my equation. Solve for that variable. (15) divided by 6. Both 15 and 6 are divisible by 3. And if I divide 15 by 3, I get 5. And if I divide 6 by 3, I get 2. So my answer as an ordered pair is 5/2, 1. I have one solution, and it's the point where both of these lines would intersect. As an ordered pair, it would be 5/2, 1. The second way we're going to solve a system is using substitution. Substitution is solving one equation for one variable and plugging it into the other equation to solve. I have 4 choices to pick from. I could pick any one of these variables, but I want to pick the easiest variable. The easiest variable to pick will be this y right here. My other variables have coefficients, so in order to solve for those variables, I would have to divide or multiply by the reciprocal. So I'm going to pick my easiest choice, and I'm going to solve for this y. Divide both sides by -1. And when I divide both sides by -1, I'm really distributing this division to both terms. This division bar is a grouping symbol that groups my entire numerator together, and I need to distribute. -4 divided by -1 gives me +4, negative divided by negative, and -6/5 x divided by -1. A negative divided by a negative is a positive 6/5 x. Now I know how big y is. Once I know how big y is, I plug it into the other equation. I'm going to keep everything in that equation the same, except for I'm going to replace y with 4 plus 6/5 x. Notice how I put 4 plus 6/5 x in parentheses. But I'm going to take 5 times y. I want 5 times all of y. How do I make sure that I take 5 times this entire y? I need parentheses. Now I just need to solve for x. Distribute. Five times 4 is 20, plus 5 times 6/5 x gives me 6x. Now solve. -6x plus 6x. I can add my like terms. Well, -6x plus 6x gives me 0. And 0 plus 20 is just 20. Well, that's odd. My variable has dropped out. When my variable drops out, I have one of these 2 cases. If my variable drops out, and I'm left with a false equation, that's when I have no solutions. No solutions, false. If my variables drop out, and I end up with a true equation, I have infinite solutions. Does 20 equal 20? Yes. How often does 20 equal 20? Always. Infinite solutions. Any solution that I can get for this first equation is going to make this second equation true also. If I were to graph these two lines, I would have coincidental lines. Last method to solve, solving by graphing. In order to graph an equation, I want to write that equation in y equals mx plus b form. To write it in y equals mx plus b, I need to solve for this y. Subtract 3x from both sides. Divide both sides by 4. And this division bar means group my numerator together and divide each term by 4. So negative 3 divided by 4 plus 8 divided by 4. My equation is now written in slope-intercept form. To graph this line, find 2 on the y-axis and graph a slope of negative 3/4. 1, 2, 3 down, 1, 2, 3, 4 to the right. 1, 2, 3 down, 4 to the right. To get a negative slope, I can go down and to the right, or up and to the left. When I connect those dots, making my line, I'm drawing in all the points that make that first equation true. All of the points on this line make this equation true. Now let's graph our second equation, negative 6x minus 8y. To graph my second equation, I want to write it in slope-intercept form. I need to solve for this y. Add 6x. Divide each side by negative 8. Six divided by negative 8 gives me negative 6/8, which simplifies down to 3/4 x. Positive 24 divided by negative 8 gives me negative 3. Graph this line. I have a slope of negative 3/4 and a y-intercept of negative 3. Connect those points. Since my lines are parallel, this system has no solutions. There are no points that make both systems true.